Hello everyone. Today the subject or the topic is based upon the subject maths. And let's dive into the chapter first. In maths, that is number system. Yes. So before knowing what is number systems, do you all guys know what is number line? Yeah, it actually looks like that. So let's mark it, and here comes the zero between the number line, and here the positive integers or the numbers marked, and here the negative integers are the numbers. So we can define the number line simply as the line segment which consists of negative integers, positive integers, and the zero. Yes. What do we locate in this number line? Yeah, in this number line we casually locate many numbers like natural numbers, whole numbers, rational numbers, irrational numbers, and more. So let's define it one by one. So let's first get into the natural numbers. So what is natural numbers? The numbers which starts from 1, 2, 3, and infinity. Yes, we could simply write this. The numbers which starts from 1 without including 0 to infinity. Examples are 1, 2, 3, 4, and so on. Next, let's move into the topic of whole numbers. And here, the another point we have to note is natural numbers are denoted by the letter Z. Means in the German, Z means Zahlen in the German word, which means countdown. Let's move into the whole numbers. Yeah, before I've said that the natural numbers is denoted by Z, but that's not the correct one. The correct one is the natural numbers are denoted by the N. And let's move on to the whole numbers. Whole numbers are the numbers which starts from 0 to infinity. Yeah, so examples are 0, 1, 2, 3, and etc. It continues to the infinity. Yeah, next let's move on to the word term integers. So as we first saw the definition of number line, even the same definition comes for the integers, and that is And the integers, the word integers or the term integers is denoted by the letter Z, which comes from the German language, which means Zahan, meaning countdown. Yes. Next the topic is, let's move on to the rational numbers. So what is a rational number? A rational number is a number which are written in the form of P by Q, where Q is not equal to 0. So some of the examples might be 21 by 24. Here the P value is 21 and the Q value is 24. Next example is 3 by 7. Here the P value is 3 and the Q value is 7. And do you think this is the correct example? 4 by 0. Is it the correct example for the rational numbers? It's not the correct example for rational number because it has been defined as it is written in the P by Q form. We accept it, but the term is which is where Q is not equals to 0. So here they have given 0 is Q, so this term is not considered as a rational number. Next, let's move on to the topic irrational numbers, which is the main part in this chapter. So before moving into the topic of irrational numbers, let's solve one question. The question is, find 3 rational numbers between 3 and 4 on the number line. So let's draw a number line first and let's locate this 3 and 4 after the 0. Okay, there is no any sign of negative, so the number don't come in the side of negative integers. Let's move on to the positive integers, and here 1, 2, 3 and 4. Yes, this is the one. Let's draw the zoomed picture of it. It looks like that actually. And between these 3 and 4, they are telling us to find any 3 rational numbers. Yes, this can be done using a simple method or formula. You might think this has a term, formula or anything. That is a plus b by 2. Here a is equals to 3 and b is equals to 4. Yes. Next, so let's substitute it and solve. A plus b by 2. A is 3 and b is 4 by 2. Here we can't cancel this 2 and 4 because there is an operation of addition in between the 3 and 4. So the answer is 3 plus 4 is 7 by 2. So this is one rational number. And to find the next rational number, this will be our a value and b value is casual, that's b is equals to 4. So this is one rational number And next, let's find it here. So second one is done here. A value is 7 by 2 plus B value is 4 by 2. That is, so let's take LCM. 7 plus 4 by 2 by 2. So here, if this go to here, it becomes reciprocal. That will be 7 plus 4 is 11. 11 by 2 is into 1 by 2. That will be our 11 by 4. This is one rational number. So this is the second rational number. And let's do the third one here. And this will be our A value. This will be the next value of A. So A is 11 by 4. And here's the third one. 11 by 4 and plus B value is as usual 4 by 2. This will later on become 11 plus 4 by 4 by 2. This will become 11 plus 4 is 15. And 4 2s are as 8. This is our third one. So let's write the solution here. The rational numbers are 7 by 2, 11 by 4, and finally 15 by 8. So yes, after this topic has been completed, let's dive into the topic of irrational numbers. Yes, irrational numbers. What are these irrational numbers? Just quite opposite to the rational numbers. Let's define it in a simple way. So that might be the numbers which are not in the form of P by Q and where Q is not equal to 0. Let's see some examples to know it better. Some examples might be the root values like root 3, root 7, root 11, root 13, and the pi value and E. E value is somewhat quite larger, so that might be not required now. So let's move into the next topic, which comes under this topic itself, that's real numbers. What are these real numbers? Yes, these real numbers comes under the topic of irrational numbers. These real numbers consist of natural numbers, whole numbers, integers, that's Z. For this rational number. Fifth is this irrational number. And one main point is it is denoted by S. Yes. So let's see it it's larger.